Okay, so here we are for lesson 11.1, a continuation of our Monday lessons. So on my screen, I have graph paper. Starting chapter 11, we're going to be graphing. So you need to have graph paper. Actually, I hope that you have printed already the worksheets that I attached to the email with the information, and you should print those and have those ready to go. Okay, so for chapter 11, this chapter is about square roots. So usually when we begin a new chapter, we begin with graphing. That's what we did in chapter 10, and we had the graphs of equations that had the power of 2. So they were quadratics, and they were the shape of a parabola. So this time, we're going to graph a square root. So on your paper, you have the table already written out, so I'm just going to copy that. And -1. And I'm going to make a graph over here to the right. Let's see. And 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, we're graphing. This is the parent function. So we're going to start with just the square root of x. That is the basic function, okay, or equation. And then we're going to add things to it. If you look on your paper, number 2 is 3 square roots of x. Number 3 is y equals the square root of x plus 2. So we're going to be doing different things to an equation of the square root of x. Now, I chose these numbers on purpose. They are all perfect squares. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4, right here on my table, is 2, the square root of 9 is 3, and I chose those numbers because they perfectly can be solved when you take the square root. Okay, so if I put, I'm going to change colors here. If I put 0 in for the square root of x, I get 0. If I put, let me show you down here, I'm putting 1 in for x, I get 1. So the square root of 1 is 1. If I put 4 in to my equation, as I said, the square root of 4 is 2. And the square root of 9 is 3. And if I put the square root of -1 in, I put that in here because I can't have a negative square root. So that answer doesn't exist. So I just wanted to put that up there to remind you all that you can't have a negative under the square root. Okay, so now something else to discuss is actually the square root of 4 is +2 or -2. But you have to have that notation on the outside. So if there's nothing there, we're just looking for the positive answer. If there is a negative out front, then we're looking for the negative answer. So for this section, you can assume that we only want the positive answer if there is nothing outside of the square root. So I hope that's clear. Normally when we take a square root, The square root of 4 would be positive 2 or negative 2. But with the notation that we have, that there's no sign there, we assume they only want the positive. Okay, so let's go back up here and graph these. So I have 0, 0, 1, 1, 2, 4, 3, oh, and we're, let's see, I did that backwards, sorry. 4, 2, 1, 2, 3, 4, 2, and 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3. And I'm going to graph it like a curve. So that is our parent function. And how that compares with a parabola, which is what we had up here, it would look something like this. This was y equals x squared, is that it's turned to the side and we only have the positive half when we don't have any sign there in front of the square root. Okay, so we want to know the domain. I'm going to write this over here so we can still look at the graph. It's underneath the table on your sheet. Okay, so the domain is the x values. Going positive, I can have any number for x. So the ones I used to graph were actually the easiest, the perfect squares. But when we draw a line, we can have the square root of any positive number in between, decimals, fractions, and all that. Okay, so do we have any negative values of x? No, because as we said before, you can't have a negative under the square root. So our domain is x is greater than or equal to 0. Okay, now the range is going up and down. So let's talk about that. I'm going to erase some of this so that we can see it better. Okay, up and down. So going up, I have values that can be anything. Eventually, this line will go up and up and up more and more rapidly. But it can go up and it can be anything greater than 0. So for the positive values of y, everything works. Now for the negative values, do I have anything down below 0? No. So my range is greater than or equal to 0. And again, that's because I don't have any sign in front of the square root. All right, let's go on to number 2. And you guys can catch up while I write this down and graph my table. -1, 0, 1, and 4. Okay. All right. So let's start again. I'm going to change colors again. This time, let's liven it up with green. Okay. So I can't have a -1 under the square root, so that's not available. That doesn't exist. So if I put 0 in for the square root, the square root of 0 is 0. 3 times 0 is 0. Okay, so basically what I'm doing is taking all of the numbers up here in my first table, way up here, and I am multiplying them by 3 every time. Sure. So, back down here, the square root of 1 is 1, so 3 times 1 is 3. Do you see how we're doing that? And the square root of 4 is 2. So I've got 3 times 2, which is 6. Again, the reason why I picked these numbers, 0, 1, and 4, is because they're perfect squares and they're easy to graph. So I'm going to graph these. I have 0, 0, then 1, 3, and 1, 2, 3, 4, and up to 6. 4, 6, up there. So my graph looks like that. All right, let's talk about the domain. It's going to be very similar. I have no negative values and I can have any positive values. So x is greater than or equal to 0. And the range is going to be the same. I can have any value going up, no values going down, and that starts at 0, 0. Okay, now there's one more question with this number 2, and that says, what happens when there's a coefficient in front of the square root of x? Okay, so what happens here is when I multiplied by 3, what happened to the graph? The original one, I'll try to graph, I'll superimpose it. So it was 1, 1, and then 4, 2. The original looked like this. So our graph got a lot wider. So you would say the graph is 3 times wider. Now remember, they have words in the back of the book like vertical stretch or vertical shrink. And I don't like those words, but that's what's in the back of the book. So 3 times wider is the same as vertical shrink, if you see that. Okay? All right. Now let's do the next one. I'm going to change back to red. Graph. Oh, do you hear the dogs? The dogs are getting hungry. I haven't fed them yet today. So let's make our table. -1. Oh, there isn't one on your paper, so you'll have to write one. 0, 1, 4, and 9. I'll fix that if I can before I send it to you. Okay. Okay, now I'm going to change colors. Let's see, this time let's do blue. I love blue. Okay, -1 is not available, so that just can't work. It's not available because that cannot be figured out there, so we don't have the +2. It doesn't just become 0, it's just not available. Now, and you'll see the difference because when I put 0 in, what do I get? 0 plus 2, which is 2. So 0 is 2, not -1. That is actually, I'll just tell you, that's called I, which is an imaginary number, and you will learn more about that in Algebra 2. Okay, so let's just erase that for now. It's imaginary for now. Okay, so we have the square root of 1 plus 2 is 1 plus 2, which is 3. And if I put 4 in, I get the square root of 4 plus 2, which is 2 plus 2, and that equals 4. And you might hear my husband talking in the background because we're all at home. The whole Strickler family is here. And then the next one would be the square root of 9 is 3 plus 2 is 5. So let's go ahead and graph those. 0, 2, 1, 3, 1, 2, 3, 4, 1, 2, 3, 4, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 5. 9, 5.
Okay, no problem.
Okay, so it looks like that.
Why don't you call that at, I'm gonna give you.
All right, so let's talk about the domain and the range. Now the domain here, if I go positive, it can be any number,
Yes.
and it starts at 0. So x is greater than or equal to 0 again. Now the range is different here because look at my graph. I can go up, but where does that start? It starts right here at 2. I don't have any values below 2. So I'm going to have y is greater than or equal to 2.
9-2, the 9-2 is her, but she is.
Okay, so let's talk about what's next. What happens when we have a constant added to y equals the square root of x? Hey dear, can you quiet down a little, please? He doesn't realize his voice carries. That's okay. All right, so what happens when we have a constant? When we add it, you can write this down. The graph moves up that amount. So that's the answer to the question. So in this case, we added 2. So it would go up 2 in this example. All right, let's just keep moving along here. Okay, we're going to do one more, and then I'm going to give you some OIOs to try on your own. Here's number 4. Graph y equals negative 0.5 square root of x. And we have the table there. Someone is brushing their teeth upstairs. I'm sure you can hear that. Okay, so let's put our numbers in. Of course, when we have negative 1, that's just not available to graph. It's imaginary. If I put 0 in, the square root of 0 is 0 times 0.5. That's 0. All right, so let's do the next one together on the paper. If I put 1 in, the square root of 1 is 1. So I have negative 0.5 times 1. So we're multiplying by negative 1/2 or negative 0.5. Okay, so I'm going to get negative 0.5. Just that coefficient times 1. So now I'm going to have negative 0.5 times the square root of 4. And the square root of 4 is 2. So I have negative 0.5 times 2. So I multiply that. And I get 1. Negative 1. So 1/2 times 2 is 1, and it's times by a negative. Okay, so let's graph this. What color will we choose this time? How about black? Okay, now I can't have a negative under the square root, so that is just not available. That's imaginary. And I have 0, 0, 1, negative 0.5, and 4, negative 1. Okay, so my graph goes down like this. Now let's talk about this, because I've told you for the last 3 examples, you can't have a negative answer here. And you cannot when you have nothing in front of the square root. If there's no sign there, that means that it's positive. But look at our equation. What have I got here? I have a negative 0.5. So now, if I put 2 in here, or 4, and I get 2, because the positive square root of 4 is 2. If I have a negative 2 on the outside, whoops, I'm sorry, it becomes negative 2. So I can have a negative graph if I have the negative outside of the square root. Okay, let's see what else is on the paper. So let's figure out the domain. All right, the domain is going to be the same. You can see from the graph we only have positive numbers and no negative numbers. All right, how about the range? And this is where there's a little change. All of my graph is now below 0. And that's because of the negative sign in front. So I'm going to have y is less than or equal to 0. And that can go on in this direction forever. Okay, so now let's look to see what the other questions are. What happens to the graph when the coefficient is a fraction? Okay, so let's talk about this. I have negative 0.5 square root of x. When I say that, I can change my decimal to a fraction, right? 0.5 is the same as 1/2. So I now have a fraction. So what happened to my graph? If I had the other half of this, this is the original going in this direction if it was negative. Can you see? It's half as wide. So the fraction makes it skinnier. So I want to write it. The fraction makes the graph skinnier. And it's half as skinny, or half as wide. Let's write that, half as wide, because we've got 1/2 for a fraction. And what happens when the coefficient is negative? When the coefficient is negative, then the graph flips below the x-axis. Okay? It flips below the x-axis. So we had 2 things going on here. We changed to a negative, so the graph flipped down here. And it's also skinnier because of the fraction. So we have both of those things going on. Okay, I want you to go ahead and do the, there are 2 OIOs there. They're on top of each other. So if you look at the worksheet, number 1, you graph to the right, and then you go down below, there's number 2. And then we'll come back to do number 5. So you can go ahead and pause the video right now and do those 2. And when we come back, we'll go over there. So please pause it now. I'm just going to keep going.
Is it lost?
Okay, so the OIOs, I'm gonna get ready here. All right, let's do number 1. I will go back to using purple, and here we go. So our numbers here are, if I put 0 in, I get 0, 2, 4, and 6. That looks familiar. Well. Okay, so I have 0, 0, 1, 2, 4, 4, and 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this was 4, 6, way up here. Okay, and the domain is going to be x is greater than or equal to 0, and the range is y is greater than or equal to 0. And if we were to ask how it compared, it would be twice as wide. Okay, number 2. I'm going to go back to red. Number 2. Here, I'll keep that down there for a moment so you can copy that. Graph y equals the square root of x minus 1. Okay. 1, 4, and 9. One, 2, 3, 4, 5, 6, 7, 8, 9. Make this a little wider. Okay. And this time I'll use blue. Love blue. Okay. If I was going to fill this in, I would have... Now this is interesting. I let you try to do this one yourself. If I put 0 in here, what's 0 minus 1? Negative 1. So in this case, because the negative 1 is outside of the square root, we have a value for y less than 0. I wanted to let you see if you could work that out on your own for just a minute. Okay, so if I put in 1 into the square root, I get 0. If I put 4 in, I get 2 minus 1, which is 1. And if I put the 9 in, I get 3 minus 1, which is 2. And the door is opening. Somebody didn't shut it next to me. That's okay. We're at home. Okay, so here I'm going to have 0, negative 1, 1, 0, 4, 1, and 9, 2. Okay, so what happened here? We have the domain now is still x is greater than or equal to 0. I don't have any points going to the left. And the range, now this is going to be greater than or equal to negative 1. So it starts here this time, going up. And I have nothing going below. And if I was to compare this with the parent equation, we would say that the graph moved down 1. Now I didn't ask that, I'm just throwing that in for extra. So we're just going to do one more problem. And then we'll be done. Okay, number 5. On your paper, graph y equals the square root of x minus 4. And yours, I got a little crowded there on the paper. So I'm going to make mine look like yours. Okay. All right. So let's see what happens. If I put, everything is under the radical. So if I put 0 in, I get negative 4. Can I have a negative underneath? No. It's all about what the solution is underneath. Let's see if I put negative 1 in. Negative 1 minus 4. That is the square root of negative 5. That's not available either. Okay. This time, if I put 4 in, 4 minus 4, that gets me 0. Okay, so my graph isn't going to start till then. If I put 5 in, 5 minus 4 is 1. And I chose 8 because 8 minus 4 is the square root of 4, which is 2. And those numbers work out very well. Okay, so let's go ahead and graph this. I've got 1, 2, 3, 4, 0. I didn't have my little red points there, markers. All right, now I would have 5, 1, and 8, 2. So do you see how this is going up here like this? So let's talk about what the domain would be. Here, my graph doesn't start until 4. So x is greater than or equal to 4. I don't have anything to the left this way. Now my range is going to be, it starts at 0 and goes up, and I have nothing going down. So my range is going to be what I've had before. And we can write that the graph moved right 4. Okay, that's how it changed. All right, that's it for everybody. I am sending